Section 16b, we're looking at increasing and decreasing functions. So we're getting used to what these words mean. So as it says here, the concepts of increasing and decreasing are closely linked to intervals. We need to take a look and refresh ourselves how intervals work in the notation that we use. So in algebraic form, if we were representing x is greater than or equal to 2, we could represent this geometrically on a graph like this. Okay, so notice that it includes 2, is equal to 2 as well as larger than 2. So the dot around the 2 here is a solid dot. As opposed to if we had x is greater than 2, it's not equal to anymore. This time the dot above the 2 is not enclosed. It's just an open circle, so it does not include the 2. Similarly, x is less than or equal to 4 would look like this. X is greater than 4 would look like this, an open circle. And in between 2 and 4, and also including 2 and 4, looks like this. We've got closed circles for both the 2 and the 4. If we write something like this, 2 is less than or equal to x, less than 4. So it's equal to 2, but not equal to 4. So you can see here that it's a closed circle and an open circle. So just a reminder of how that works. All right, so if we are just taking a look at this blue box, suppose S is an interval in the domain of f of x. That just means our function. So suppose S is an interval in the domain of the function. So the function is defined for all x that are in S. Okay. Now f of x, the function, is increasing on S if and only if. Please remember that this notation here means if and only if. That means that this statement works in both directions. The function is increasing on S if this is true. If this is happening, then the function is increasing on f. So if and only if. It works in both directions. So the function from a to b for all a, b is an element of S such that a is less than b. All right, so what does that mean? Again, we just need to decode what's being said here in our mathematical speak. The function is increasing if going from the left to the right on our domain. Okay, so we're saying that a is less than b, b is greater than a, and f of a is less than or equal to f of b, then that would be an increasing function because it's going to be something in this direction graphically. Other way around, again, if a is smaller than b, but when we plug a into our function, it gives us a greater number than when we plug b in, then that's a decreasing function. So if we look at an example here, we've got y equals x squared, our most simple parabolic function. People often get confused about the point x equals 0, so this point right here. This function is decreasing if x is less than or equal to 0. So on this part of our graph, the function is decreasing. Okay, why is it decreasing? Because if we look from left to right, it is coming down. Okay, so decreasing. If we look at for x is greater than 0, so in other words, we're looking at this portion of the graph, somewhere in here, x is greater than 0, this portion of the graph is increasing. Again, looking at it from left to right, this is increasing. It's getting bigger. So this is an increasing function. And when we're talking here about, sometimes we might think we're getting confused at this turning point here. Just remember that that turning point belongs to both the decreasing part and the increasing part. So once again, this function is decreasing when x is smaller than or equal to 0, and this function is increasing when x is bigger than or equal to 0. Here's just another way of saying that f of x is increasing on s if and only if the derivative is greater than or equal to 0. Okay, we'll talk about what this means as well. The function is decreasing on s if and only if the derivative is less than or equal to 0. Okay, so does this make sense graphically? We're saying that f of x, the function is increasing if the derivative is greater than 0. Okay, so increasing if the derivative is equal to 0. Now the derivative refers to the slope of the tangent. So any tangent line along here is going to have a positive slope. So that totally makes sense. Okay, all tangents have a positive slope, a positive gradient. And please remember to figure out a way to take notes here. I'm not actually drawing on the notes, but you can do that. Okay, so all the tangents have a positive gradient when the function is increasing. And keep in mind that f, the derivative, is greater than or equal to 0. Okay, similarly over here, when we look at this, this is decreasing. Okay, decreasing, and it's decreasing. If we think about the tangents, every single one of these tangent lines is a negative slope. Okay, all tangents have a negative slope, negative gradient. Therefore, f of x is decreasing. And also, the derivative is less than or equal to 0. Okay, so these two things mean the same thing. This and this mean the same thing. The derivative is less than or equal to 0. All tangents have a negative gradient. Okay, smaller than 0. These two things mean the same thing. All tangents have a positive gradient. The derivative is greater than or equal to 0. Monotonicity. So some functions are only increasing or only decreasing, such as these exponential functions. So this one here, y equals 2 to the power of x, is only increasing. It's an increasing function. And this one here, y equals 3 to the power of negative x, is decreasing.